at examples with calculus and parametric functions. You were given all of the formulas you need to know yesterday, so we're going to be using lots of those formulas, answering lots of questions. The first question is a common AP question, which you've probably noticed it's a common AP question at this point, is to find a tangent line. Well, a tangent line on a parametric curve is still defined only in xy, right? Because a tangent line would not have to do with time. So I need to find the equation of the tangent line, which means I need y minus y1 m times x minus x1. So I need the slope. So the first thing I want to find is dy over dx. And how do I find dy over dx on a parametric curve? Good. I find dy dt, divide by dx dt, right? dy dt is and dy dt, and dx dt is, I do want that at t equals 3 pi over 4, which is cosine of 3 pi over 4. We might need to do a little work to get that. It is 3 pi over 4 is in quadrant 2. It is a 1, 1 radical 2 triangle. So if you forgot the unit circle, draw a picture. It will be okay. So you get cosine would be negative 1 over radical 2. Sine would be positive 1 over radical 2. Because those are the same thing except opposite signs, they will divide out to just give you 1, and that's where the 3/4 comes from. However, it is positive 3/4 because one of them was negative. Do I need to show more work than that? I can if you want me to. You sure? All right. So, how do I finish? Now, what is dy dx in terms of the tangent line? Yeah, that's m. How do I find x and y? Plug in 3 pi over 4 into the x component and the y component. Cosine of 3 pi over 4, radical 2 over 2 if you want it rationalized, it is negative. So 4 radical 2 over 2 or 2 radical 2. Am I going too fast on that unit circle stuff? And, oh, wait. I did do it wrong. That's cosine. That's x. And was it negative or positive? What was it? I already forgot my answer. That looked better. Okay. And then the y value, sine is radical 2 over 2, so 3 radical 2 over 2. And it is positive. Okay, any questions about that? Common question type, they will ask you to find tangent lines in parametric form quite often. Find all points of horizontal and vertical tangency. How would I go about that? Okay, good. I need to find dy dx. Step 1, anytime I'm talking about tangent lines, probably a good idea to start with dy dx in any format, right? So dy dx would be 2t minus 3 over 2t plus 1. Yes. When will I have horizontal tangent points? when the top equals 0, when the dy dx equals 0, and fractions equal 0 when the top is 0. And when will I have vertical tangents? The bottom is 0. When dy dx is undefined, and again that happens when the bottom equals 0. Am I done when I find t? What does it ask? Find all points of horizontal and vertical tangency. What does a point consist of? An x value and a y value. How would I find such a thing? Plug in 3 over 2 into the x and the y, and plug in negative 1/2 into the x and the y. So 3 over 2 and for x. I'm going to do this completely by hand just for practice purposes. I don't know if this was a calculator question or not. So x of 3 over 2 would be 9 over 4 plus 3 over 2. Everyone know where I got that? This is 6 over 4, so 15/4. Is the x value. Y of 3 over 2 is 9/4 minus 9/2. If y'all see me do something wrong, let me know. This would be 18/4, so negative 9/4. And that would be 20/4, right? So 11/4. Check my work, please. I think it's 11/4. Any questions so far? You good? You sure? Okay. (1/4 minus 1/2), negative 1/4. If you notice a mistake, please let me know. Minus, oh, that would be plus 3 over 2. Plus 5. 6/4, 20/4, 27/4. Again, if that's calculator, then it's really easy. And it may be, I don't know. But anytime we can practice our 5th grade math skills, it's always good to pull those up. Any questions about that one? All right. Set up an integral expression for the arc length of the curve given by those parametric equations. I'm going to give you a minute and see if you can do that. Glance at Shelby's notes for the arc length formula. Was anyone else not here yesterday? I think. So see if you can set that up. The test. Well, actually, Tuesday next week we'll have a parametric quiz. Just a quiz over the parametric stuff. Yeah, you'll want the formulas memorized for that. No. So Tuesday, you'll want to have the formulas memorized. Good question. Sure. Sure. Remind me. Yeah, it is. I think a couple people have already gotten them. Came and taken pictures. But we can do that at the end of class. Just take pictures of the keys, take them home with you. I'll get them out. I'll do that right now while you're doing this. But the gateway exam over this won't happen until after the next chapter. But you will need to know the formulas for this chapter. We only have 2 chapters left, and then we are done with new material. That's how much time we have. It is the first time I have taught these 2 chapters, so I'm going to see where we... This particular one, I have about 4 weeks mapped out. So that'll take us to the end of January with this chapter. The next chapter I haven't mapped out day by day yet. So I don't think it will take us all the way till spring break. I think we will finish a couple weeks before spring break, but we have the time if we need it. In this class we have lots of time if we need it. There are only 3 additional chapters in BC than AB, and you have a full extra semester. So it really works out where you have lots of time. Okay, are we ready to try this problem? Okay, first of all, you tell me the formula. What is it? Okay, so I'm going to go ahead and say 0 to 1.
And then the square root of dx dt squared plus dy dt squared.
Those are wanting to write. Okay. Right? Correct? And it does say do not evaluate, which is nice if it turns out to be a yucky integral. A lot of these will probably end up on the calculator part of the exam, so you'll set it up and then type it in, or they'll say set up but do not evaluate. So I have the integral from 0 to 1 of the square root. Dx dt would be 2t. Plus dy dt would be 12t squared. Is that right? That is the arc length. Any questions? So that is a formula you are expected to have memorized on the AP exam. On that one it said don't evaluate, but sometimes it will say evaluate, so I don't know if I'd call it a waste of time, but on that one you didn't need to do it. Okay, let's look at this one. X equals t squared minus 4, y equals 3 sine of t from 0 to pi. So sketch the curve, find the highest point on the curve, find the length of the curve. I think that's the last question. So try this one. I'm going to pause this time. Okay, before we answer this question, I do want to go give you the homework. We probably won't quite finish all of these notes today. We have a little bit of time Monday, but I do want you to know we've answered everything you need to do the homework. All we're doing from now is just examples, just working more problems in class. On Monday, you will get some AP multiple choice problems on parametric. I'll probably hand them out tomorrow, but that'll be your Monday night's homework or Monday during the day. So these are your problems that are due Monday.
So it's tomorrow.
Gateway.
Oh, that's right.
Monday. All due Monday. So tomorrow we aren't learning anything new, but it won't necessarily be a work day either because you have... now once you finish your gateway exam tomorrow, then it becomes a work day, but how early you finish, I don't know. But this is a 2-day assignment. It probably is not a long 2-day assignment. What is it, 12 and then 6, so 18, 19, 20, 21 problems. So nothing crazy. And if you look at those problems on that worksheet, they don't look terrible, right? We can do this. Oh, go back. If you make 100 on it? Sure. If you make 100 on the quiz tomorrow, I will give you 5 bonus points. Yes, that sounds wonderful. She asked if there are bonus points tomorrow. And I said, if you make 100% on all 4 of those gateways, I will give you 5 bonus points. I will. No. But you know what? If you pull a 100% on all 4 of those, I will give you bonus points. I will be impressed. Honestly, Patrick, if you really sit down and memorize, you could do it, you know?
I need to study for it.
Yeah, studying is good. And since you technically don't have any homework you have to have done tomorrow, you could just study if you wish. I understand. Okay, sketch the curve. What would you do to sketch the curve? Okay, pick some points. Okay, 0, plug in 0, and I get -4. And what'd you say? -4. We'll pick that too. Good, -4, 0. I'm going to have to look over here. Okay, -4, 0. Very good. Okay, you could do pi over 6. Why is pi over 6 kind of nice?
It makes nice.
Sine of pi over 6 is a half, so it's not a radical answer, so it is usable as far as writing down that point. So the sine of pi over 6 is a half, so a half times 3 is 3/2. Problem comes in, you have pi over 6 squared minus 4, which is pretty yucky. So pi squared over 36 minus 4. I am okay if you pick up a calculator and get a decimal for that. What is it? See, pi squared is Like divided by 36. Yeah, so it's a fraction answer. 1/4 3/2. Is that what we got? So fraction 3/2. And then pi over 2. Pi squared over 4, is that what you said? Hold on, did we subtract 4 from the 1/4? Uh-oh. We did on the previous one. So subtract 4 on that x, so that should be... Hold on, I don't know. Oh, here, do this one in the pi over 6 in your calculator. Do that pi over 6 value in your calculator. Get decimal for me.
3.7.
Yeah, that looks better. Up here. Alright, and then pi over 2. What did we get when we did pi over 2 squared minus 4? Negative 1 point what?
5.
Negative 1.5 for x.
Yeah.
Approximately, not exactly, right?
No.
Okay. Negative 1.5 and then 3. Is that right? And then okay, I'm just going to skip to pi. Pi squared is 9 something minus 4 is 5 something. Everyone agree? Sine of pi is 0. Does that look right? Okay, just for mental notes here, t would be the square root of x plus 4. So you would end up having the sine of the square root of x plus 4 if you were to look at the function. It's a little yucky, but you could do it. Okay. The direction of the curve is going this way. Hold on. And if you wanted to put more points in, you could. Something like that. Sorry about my bad drawing. Okay, so we have a sketch. Find the highest point on the curve. How would you do that? What do you need to know if you want the highest point on the curve? The maximum of what? The y value. Do you need the maximum of the x value to find the highest point? No. So I'm going to find the derivative of y. Set it equal to 0. So I really want to know when is cosine of t equal to 0, and I do only care between 0 and pi. So when is cosine equal to 0? Pi over 2. So t is pi over 2. Is that the highest point? No. What is that? That's the t value. How do I find the point? Plug it back in. So since it does say point, that leads me to think an x and a y value. If it did just say what's the highest value, then we would just need a y value. The y value would be 3, right? Everyone agree? Sine of pi over 2 is 1. The x value would be pi over 2 squared minus 4. As you know with AP, you could either leave that as pi over 2 squared minus 4, or you could go find an actual value depending on if you were calculator or non. If you were non-calculator, my answer would look like that. I wouldn't try to do anything weird with that pi over 2 squared. Do what? It does say find the length, and so that probably will give us an insight into whether this was a calculator or a non-calculator question. 0 to pi square root of, I already know this one, so 3 cosine of t squared, and the other one, 2t. Everyone agree with that? Does that look like an integral that you're going to be asked to do by hand? No? So since it does say find the length of the curve, type that in your calculator for me. Now, if that happened to involve, if the original happened to involve sine, you could find the length, because that would, if you could make it into sine squared plus cosine squared, you could get just a 1 and have some things you could work with. But and then some of them, if they just involve t's, you could do a u substitution on. So there are ways they could make this doable by hand. This is not one of them, though. This is not that case. So what do you get? Square no, sorry, just units, not square, because this is arc length, not area, right? I don't know what our units are in, but any questions about that one? How are those gateway keys coming? Are they somewhere? Oh, I've got them. Did everyone get them? Okay, awesome. All right. Tangent line when t equals -1. Another tangent line. If you can tell, if I'm doing 2 of these in the notes, very common AP question for them to ask you to find a tangent line on a parametric function. What would you do first? Slope. dy dx, which would be 4t cubed over 4t, which is just t squared if you want to simplify. So -1 squared is 1, so my slope is 1. My y value is also 1. My x value, 1 squared is 1, 1 times 2 is 2, 2 plus 3 is 5. Questions about that? Let's see. Are we good with the derivative and the second derivative? We do enough of those yesterday. We want to see another one. Enough yesterday? Okay, let's do it then. So first derivative. You have to do the first derivative before we can do the second derivative. The first derivative is 1 over t divided by -1 over t squared. How did I do that derivative so fast? How did I do dx dt so fast? Good. Call that t to the -1. So I get -1 t to the -2. Does everyone agree? So dy dx, remember, is dy dt divided by dx dt. That does simplify to just be -t, correct? Remember, the second derivative of y with respect to x. What is the formula for that? Okay, good. It's the derivative of dy dx with respect to t, which is -1. divided by the derivative of x with respect to t, right? dx dt. What was dx dt? You should not have to find it. It should be somewhere already written in the problem. Negative 1 over t squared. So let me go back and show you what formula I'm using here. Okay, remember we've got the derivative of dy dx with respect to t divided by dx dt. So dx dt we already found. We had to find the derivative of the derivative and divide that by dx dt. That is how you do the second derivative on parametric, which is t squared. Any questions about that one? We will stop there for today. I have another example. We'll probably wait to do it until Monday. Like I said, this example is not anything that you can't do your homework without. It does ask speed, and we haven't done a speed example. However, you have a formula, use it. So if you need speed, use your formula, find speed. We'll do this example on Monday.